Today in this video, we are going to learn how to analyze a DC resistive network using Thevenin's theorem. The circuit which we are considering for the analysis is on our screen, and in this network, we have to determine the current flowing through the 6 ohm resistor using Thevenin's theorem. Before we apply the Thevenin's theorem, we must remember that as per the Thevenin's theorem, any linear two-terminal network, no matter how complex it is, it can be replaced by a simplified circuit consisting of a voltage source called as the Thevenin's voltage source and a resistance in series. This voltage source and this equivalent circuit is called as Thevenin's equivalent circuit. So let us determine the current flowing through this 6 ohm resistor using Thevenin's theorem. Before we apply the Thevenin's theorem, we must remove the load resistance from the network, as we require a two-terminal network to find its Thevenin's equivalent. When we remove this load resistance from the network remaining will look like this one. And these will be the two terminals which we get after removing the load resistance. Now, this network can be replaced by an equivalent network called as Thevenin's equivalent, consisting of a voltage source and a resistance in series. Now, we have to determine the values of these VTH and RTH first. So let us try to have the value of the VTH first. So calculate the value of VTH. VTH is the voltage that will be appearing across the open terminals A and B. So to determine the voltage across A and B, we must know the values of the currents that will be flowing through the resistors. So let us determine the current first that will be flowing through the resistors of this network. I am using the mesh analysis method to determine the current flowing through each resistor, and while applying the mesh analysis, I can see that there are two meshes in this circuit. As for the third one, these are the open terminals and no current can pass through these 2 points. So this will be the mesh 1, and I am assuming that current I is flowing through this mesh I 1, and for the mesh number 2, the current flowing we can directly take to be as 4 ampere, because a 4 ampere current source is connected in this mesh. So only unknown current is I, and we can determine the value of this I by applying the KVL through this mesh. Let us determine the value of this I first. For determining the value, I am starting the applying the KVL in this mesh from this point. While applying the KVL in this mesh, first we will have a 4 drop as 4 into I across this 4 ohm resistor. Then we can take it as minus 32 as a drop of this battery, plus 12 into I as a drop across this resistor, and this must be equals to 0 as per the KVL. In this, from this equation, we can easily determine the current equals to 2 ampere that will be flowing in this mesh. Now let us determine the value of VTH. VTH is the voltage across these 2 points. So we have to start from A and has to come to this point B while applying the KVL. We can choose any of the path, but keep it in mind, we should not take on that path where we are having a current source. So we will not be considering this into the path, but yes, any other path of this network can be used for the calculation of VTH. Suppose I am taking on this as a path for the calculation of VTH. So when we start from A, first we will be having a 12 ohm resistor, and through this 12 ohm resistor the current flowing is 2 ampere. So drop will be 12 into 2. Then we'll come to this 9 ohm resistor where the current is in opposite direction. So we'll take the drop as minus of 9 into 4. So this will be the value of VTH, and this will be coming out to be 24 minus 36, that is equals to minus 12 volts. Alternatively, we can find the value of VTH by using this path where first we will be having a 32 volts battery, right? So alternatively what we can do is I can use a second path. Suppose I am using now this one, this path for finding the VTH. So what we'll be having is, first we'll be having a 32 volts battery, then a 4 ohm resistor, but now the current flowing through this 4 ohm resistor is in opposite direction to us. So it will be 4 minus of 4 into the current, that is 2, then coming to 9, and again the current flowing in the 9 ohm resistor is opposite to our direction. So it will be minus 9 into 4, and again it will be 32 minus 8 minus 36, and that will be equals to minus 12 volts. So VTH will be equals to minus 12 volts. That means it is in opposite polarity of a 12 volt magnitude. Let us determine the value of RTH for this network. When we determine the value of RTH, we must understand that first we have to deactivate first we have to deactivate all the sources of the network. So while deactivating, what we do, we do the short circuit for the voltage sources. So voltage source, in place of the voltage source, will be doing short circuit, whereas in place of the current source will be doing open circuit. After deactivating the sources, the network which will remain will look like this one, that we are having A and the B as two open terminals. There is a current source in this branch, so it will be open, and there will be a 4 ohm resistor. Then in the second branch there is a resistor of 9 ohm. There is a 32 volts battery, so we'll be short circuiting the battery, and then there is a 4 ohm resistor connected to this network. In the fourth branch there is a 12 ohm resistor. So this will be a network which will remain after deactivating the sources. Now to determine the net value of resistance, that is termed as RTH. RTH is the net value of resistance of the network seen from the terminals A and B. So what we do now, we will try to circulate the current to know whether the resistor are in series or in parallel. So when we flow the current through this A, the current is going to divide among these two resistors at this node. After reaching this node, the current is again going to combine. But see, at this node, no current is going to pass through this 4 ohm resistor as there is a open terminal. So no current will pass through 4 ohm resistor, and the current which will be there at this node is going to pass through this resistor of 9 ohm directly. So the RTH for this network will be having a 9 ohm resistor that will be in series to the parallel combination of these two. So it will be a parallel combination of these two, that is 12 into 4 divided by 12 plus 4, that is 16 plus 9, and this value will be equals to the uh, 4 4s are 16, 4 3s are 12. So RTH will be equals to 12 ohm. So in this way we can determine the net resistance, which is called as the Thevenin's resistance for a network, and this RTH coming out is equals to 12 ohm. So now we have determined the value of VTH and RTH. But our final objective was to calculate the current flowing through the 6 ohm resistor that we have disconnected from the two open terminals A and B. Now, to find out the current flowing this 6 ohm resistor, will be again connecting the load resistance to this equivalent circuit, and the circuit which now will be of this manner. Now, in this, we can easily determine the current flowing through the 6 ohm resistor. Let us determine the current flowing through the 6 ohm resistor using applying the KVL, and the network which we are now having is a voltage source of 12 volts and a resistance of 12 ohm. We have connected back the load resistance of the 6 ohm, and we want to determine the current flowing through this 6 ohm resistor. Let us take it as IL. So easily the value of IL will be the VTH, that is 12 volts, VTH which is 12 volts, divided by RTH plus RL. If this is VTH, this is RTH, and this is IL, so IL will be equals to VTH divided by RTH plus RL. So easily we can have a value of IL, as we know the value of VTH to be 12 volts, RTH to be 12 ohm, and RL to be 6 ohm. So value of the current will be 12 by 18 ampere for this network. Thank you. Hope you have understood the analysis of networks using Thevenin's theorem.